So let's begin our conversation about electrical for gas with talking about what electricity is. Okay, so we have all matters are made up of atoms, which are made up of particles called protons, neutrons, and electrons. Protons have a positive charge, electrons has a negative charge. Neutrons have no charge and have no electrical effect. We have to think about electricity as a potential difference. An imbalance of electrons is called a potential difference or electromotive force. A potential difference can be created by friction, which would be static electricity, chemical action, which is batteries, magnetic activity, which would be generators, thermoelectric, which would be heat, and photoelectric, which is light. The unit of measure for this potential difference, or EMF, is called the volt. To measure volts, we're going to use meters. Voltmeters are used to measure potential difference between two specific points. Voltmeters are available in analog or digital types. Most often in the HVAC field, you're going to be using digital. So the potential difference must exist for a meter to register a volt reading. Okay, so if you take a look at the first diagram, the one on the left, you'll see that the voltmeter is before the open switch. And we'll go more into schematics in a little while here. There's an open switch here, but I have 120 volts to neutral. So line to neutral. So I have a difference between neutral and line of 120 volts. That's what my meter is going to read. In this case, on the right diagram, I have a closed switch and a light bulb that has, if you look closely, you'll see a broken filament in it. Okay, once again, I have voltage across that light bulb is 120 volts. There's a potential difference between line and neutral. So we have to have a potential difference for the meter to register a voltage reading. The voltage tester reads 0 when there's no potential difference. Likewise, if the voltage is 120 at both probes, the meter reads 0. So again, when we have here, we're after this open switch, so there's no voltage at this point to neutral. So there's no potential difference. Here, both probes are on the same part of 120, no potential difference. So if there's no difference, your voltmeter is going to read 0. Now, you have to be really careful about this because you may be reading the same potential, no difference between two probes. Okay, so in this case, you may actually think that the voltmeter is showing you 0 volts, but if you touch this circuit and was grounded or standing in a little bit of water, you could get a shock because that is 120 volts on that light bulb. There's just no path to neutral. So what you would actually do is you would take a second reading from the right side of that bulb to neutral, and you would find that there's 120 volts difference. Never touch an electrical wire because of a 0 voltage reading that was obtained. Always do multiple checks. Amperage, ampere, amps, and current are terms used to describe the quantity and intensity of electrons moving through a conductor. When current flows through a conductor, a magnetic field is created. The clamp-on ammeter is most commonly used on AC circuits. Resistance is the opposition to current flow. So electron flow is energy in motion and has to be controlled. Resistance refers to anything offering opposition to current flow. There are several types of resistance that will be discussed, but a basic understanding of Ohm's law is necessary before that discussion. So let's talk a little bit about Ohm's law. Ohm's law is the relationship between voltage, amps, and resistance. And again, in Ohm's law, the letters E, I, and R stands for voltage, amps, and resistance. They can be expressed mathematically in a formula, E equals I times R. Therefore, if two values are known, you can solve the equation to find the other. So on the next slide, I'm going to show you a pie chart example that will help you remember this formula. It's very important. So the Ohm's law of pie charts are actually pretty simple. Using the pie chart, cover the value you want to find. So in the first case, by covering the I, you see the formula is E over R, which is E divided by R. In the second case, by covering the R, you see the formula is E divided by I, E over I. In the third example, by covering the E, you find that the formula is E equals I times R, because any two letters next to each other is multiplication. So your three variations of Ohm's law is amperage equals voltage divided by resistance, resistance equals voltage divided by amperage, or voltage equals amperage times resistance. Now, you're going to work a lot more with Ohm's law, but one of the things we have to realize is that there's several types of resistance. We have pure resistance, we have inductive reactance, and we have capacitive reactance. Pure resistance remains constant, such as in a heating element or an incandescent light bulb. Inductive reactance is caused by the magnetic field that develops around a conductor, especially in coils or motors. Capacitor reactance goes along with capacitors that store and discharge electrons that create opposition to current flow. The total of pure resistance, inductive reactance, and capacitive reactance is called impedance. An ohm meter is used to measure pure resistance. Batteries inside the meter provide a power supply to measure electron movements. Never connect an ohm meter to a circuit with the power on, or damage to the meter may occur. Also be sure that the component you're measuring is electrically disconnected to prevent feedback circuits and false readings. Resistance can be calculated on a live circuit by measuring voltage and amperage, and then using Ohm's law, which is voltage divided by amperage, to equals resistance. So the key is for measuring resistance, do not use it on a live circuit. Make sure you isolate the component you want to check the resistance of. Okay, because in most circuits, most HVAC equipment, there's multiple paths. So you want to make sure you isolate just the component you want to take the reading of. Wattage is another term we're going to talk about. Electrical power is the rate at which electricity is used to perform useful work. The work performed is measured in units called watts. Watts are calculated by multiplying amperage times voltage. So W equals I times E. 746 watts is equal to 1 horsepower. Again, horsepower is another unit of work. So we have what's called a wheel of electricity that puts all of this together. So voltage, which is E, amperage, which is I, ohms, which is R, or watts, which is W, can be calculated if you know two of the values. So for example, if I know voltage and resistance, I can calculate amperage. If I know voltage and amperage, I can calculate watts. If I know amperage and resistance, I can calculate watts. So any of these can be calculated if you know two of the values. But it all comes back to the basics. E equals I times R.